This is the video for section 7.1, part 2. In this video, we're going to look at some of the ideas like area being probability and the empirical rule and some other things that go along with that normal curve. All right, so this idea that area is probability extends to any density curve. So we just saw it with a rectangle. Area had to be 1. We found the area of the rectangle by using geometry. But when we have a normal curve, that area has to be 1 as well. So remember our normal curve from chapter 2 and chapter 3 with the empirical rule? That area also has to be 1. So if I could find the area, of this, if I could find this area, then I could know the probability. This could also be the probability that x is bigger, than, k. That's what that shaded region would be. So our area, our calculators and our StatCrunch gives us the area. But the area is probability. They're interchangeable. All right, so we've talked about the normal curve before. It's symmetric, single-peaked, and bell-shaped. And there's actually lots of different normal curves. And so here's some examples where we can see that the normal curve doesn't just have one shape. A lot of times when we draw it kind of like this red one that you see. This one here that's going like this. And that's one where the mean, in this case, is at 0, and the standard deviation is 1. That's kind of how we'll end up drawing most of our curves, just because it's kind of the standard look. However, this blue curve is also a normal distribution, a density curve for a normal distribution. It has, if you notice right here, a standard deviation of 0.2. So it has a smaller standard deviation. So it's narrower and taller. Now, as opposed to this kind of gold or tan or yellow curve here, this curve has a standard deviation of 5. And so it's much more spread out. So if we think about that empirical rule where 68% is within 1 standard deviation, well, for this gold curve, 1 standard deviation is this entire, like if our standard deviation is 5, then 1 standard deviation is here, and then to the left is here. So 68% of the data is under this part of the graph. And then our last one here, this green one, also a normal curve. It just has a mean somewhere else. So it doesn't matter where the mean is. These were just at 0 kind of as a reference point. And it also has a standard deviation of 0.5. So narrower than the first one I talked about, the red one, but not so narrow as the blue one. So normal curves can look very differently when we graph them, but a lot of times when we draw them ourselves, they'll kind of all look like the red one. All right, the other thing, that is symmetric, it is bell-shaped, and remember the mean, median, and mode all fall in the same place. Since the median and the mean are in the same area, then 50% will be to the left, 50% will be to the right. So those are some things to remember about the normal curve. All right, hopefully you remember the empirical rule, or at least that there is an empirical rule. That's our 68, 95, 99.7 rule. And those numbers are percentages that are within 1, 2, or 3 standard deviations away. So there's our image from chapter 3. You might recognize that. Depending on what our mean and standard deviation are, we fill out these numbers. And then we can know things about the percentages or area or probabilities for the normal distribution. Now you may think, well, we've already done that, so what's the big deal? Well, what if we aren't exactly 1, 2, or 3 standard deviations away? Then we have a bit of a problem. And in fact, this is one of those instances where we're going to have a cliffhanger and we're going to be to be continued. So we'll talk more about how we figure out the area when we're not exactly 1, 2, or 3 standard deviations away by doing some things in section 7.2.